So what was the last problem that we did? What was the last problem? Can you tell me the equation? Last problem's equation or answer?
Sir, e power minus t into 1 plus 2t.
Okay. E raised to e to the power minus t minus e raised to minus 2t. Okay. Now write the next question. Determine the natural response. Determine the natural response for the system described by. Determine the natural response for the system described by the following differential equation. For the following differential equation. D square y of t by dt square is equal to, sorry, plus 4y of t is equal to 3 dx of t by dt. Given y of 0 is equal to -1 and dy of t by dt for t is equal to 0 is equal to 1. So these are the initial conditions given. So we are there to find your natural response. Now what do you mean by natural response? While performing the natural response, you have to set your input as 0. So kindly rewrite the given equation. That is, your RHS will become 0. Right hand side of the given equation will be 0. So this equation will go like this: d square y of t by dt square plus 4y of t will become 0. Correct. Why we are setting right hand side as 0? Because we are finding the natural response. While finding the natural response, your input should be 0. Now we need to write the characteristic equation. So can you tell me what is the characteristic equation, anyone? What is the characteristic?
Sir, r square plus 4r is equal to 0.
R square plus
R square plus 4R.
R square plus 4 equal to 0, not 4R. See, if you are putting the second derivative, then it will be R square. Okay. For first derivative, you will be putting R. Correct. If there is no derivative, means you will be putting it as 1. This is the way of writing the characteristic equation. Okay, if there is second derivative, means we will be putting R square. If it is the only first derivative, means we will be putting R. If there is only y of t, we will be putting 1. So here we are having second derivative, so we put R square plus 4 is a constant, and instead of putting y of t, we will put 1. So R square plus 4 is equal to 0. Now all of you find the value of R. All of you find the value of R. R square is equal to -4 means R is equal to plus or minus 2j, correct? Root of -4 is plus or minus 2j. Now from this, how we are going to find the solution? By n of t. What is the general format of writing the solution? If the roots are complex numbers, you can say that here the roots are complex, isn't it? Plus or minus 2j. So have a look into those notes, whatever I have dictated in the previous class. You have 3 different cases. One case was real and distinct roots, second case was equal roots, and third case was complex roots. Correct. So what is the value of what is the real value here? What is the real term over here? Plus or minus 2j means real component is 0, correct? Real is 0 and imaginary term is 2. Correct? So how you are going to write this equation? What is the general formula? E raised to 80 into C1 cos bt plus C2 sin bt. This is the general solution of natural response for which case? Complex roots. As of now, we had complex roots where the real part is 0. How did you got the real part as 0? Because there is no real part over here. As you can see, the real part is 0 and imaginary part is 2. Okay. So we have written e to the power 80 into C1 cos bt plus C2 sin bt. Now substitute over there and rewrite the solution. So this will become e to the power 0 into C1 cos 2t plus C2 sin 2t. C1 cos 2t plus C2 sin 2t. E to the power 0 is 1. So it will be C1 cos 2t plus C2 sin 2t. Now we need to find the value of C1 and C2. So for that we will make use of our initial conditions. What are our initial conditions given? These are the two initial conditions that was given in the question. One is y of 0 is -1. Second one is dy by dt at t equal to 0 is equal to 1. So first we will go for the first initial condition. Y of 0 as -1. So for that put t is equal to 0. So -1 is equal to C1 cos 0 plus C2 sin 0. You know that sin 0 is 0 and cos 0 is 1. So it will be, from this you will get, this will get cancelled, isn't it? So C1 is equal to -1. C1 is equal to -1. Similarly, you need to find C2. So for that, we will make use of the second initial condition. This was the first initial condition given in the question. All of you take down. If any doubts, please ask me. In this problem, you did a complex term. Okay, you have come through a complex term. That is why we took this case as a solution. We have three distinct cases. Hope you have taken those notes in the last class. One was real and distinct case. Second was real and equal roots. That also we did in the previous problem. Third one was complex roots. For the complex roots, we are having this kind of solution. Now to find C2, what you will do is you will take the second initial condition. Now what is the second initial condition that we have? dy by dt at t equal to 0 is 1. dy by dt is equal to 0 is equal to 1. This was the initial condition that is given. Already we have y with us. That will be equation number 1. Now you differentiate that. Already we have y of t, that is c1 cos t. What is that? C1 cos 2t plus C2 sin 2t, right? C1 cos 2t plus C2 sin 2t. This was your y of t. Now we will differentiate this, that is dy of t by dt is equal to, one of you can tell me the answer after taking the differentiation. Manoj Kumar 73, tell me the answer after taking the differentiation. See, one more thing, many of you are not attending your life skills class. Why you are doing like that? It is very important. Okay, you may be thinking that life skill is easy to pass and all, but other than that, it is very important subject. Okay, when you come to your placements, you know that one of your rounds will be verbal ability and essay writing. Many of the companies like Cognizant, today we are having Cognizant Drive for your seniors, your final year students. Okay, there they are having a verbal ability round, come essay writing. So please don't miss those classes. You won't get any other chance for improving those skills. So it is very important. I want you people to regularly attend those classes. Not even that, all the technical subjects you have to attend. Many of the students out of 84 or 74 students, only 45, 50 students are, I mean, only for 45. I can say only 40 students are regular. The remaining 40 students are not attending the classes. Means 50% is your total attendance from your class. It will be viewed very seriously. At the end of the semester, you will be charged fine for that. Okay. And you won't be able to write your SE examination also if minimum attendance criteria is not satisfied. So please keep it in mind and act accordingly. This is final warning for you. So now you will take the differentiation. Yes, tell me, who was that? Manoj, yeah. Manoj, tell me dy of t by dt. Take the differentiation and tell me the answer. Manoj is not responding. Manoj, unmute and speak. Nishant.
Sir, minus 2C1 sin 2t plus 2C2 cos 2t, sir.
Okay. Very good. So this was a derivative. Derivative of cos 2t is minus 2 sin 2t. Now you will put again 0 from this because it is given at t is equal to 0. The initial condition is given for t is equal to 0. So you will put t as 0. So this will again become 0. Sin 0 is 0, right? Sin 0 is 0 plus 2c2 cos 0 is 1. Again, this value, what is the value that is given for dy of t by dt? The second initial condition is 1, correct? So 1 is equal to 0 plus 2c2, which means that 2c2 is equal to 1, implies c2 is equal to 1 by 2. C2 is equal to 1 by 2. Correct? So as of now, we got C1 and C2. Once you got these two values of C1 and C2, you can go for the first equation and substitute. Means our solution. Our solution was yn of t, that is natural response. N signifies the natural response. This is nothing but C1 cos 2t, that is minus cos 2t, plus what is C2? C2 is half sin 2t. This is your final answer of natural response. So in order to solve C1 and C2, you should make use of two initial conditions, substitute the values, and then you need to solve C1 and C2 and go back to your solution and substitute and rewrite the final answer. One more question. Find the natural response for the system described by the differential equation. For the system described by the differential equation. D square y of t by dt square plus 2 dy of t by dt plus 2y of t is equal to dx of t by dt. Given y of 0 is equal to 1 and dy of t by dt at t equal to 0 is equal to 0. These are the initial conditions that is given. I repeat the initial conditions once again. Y of 0 is 1 and dy of t by dt at t equal to 0 is equal to 0. Now, Nikhil, you tell me what I have to do first. Since this is a natural response, what I have to do? Nikhil, unmute and tell me what you have to do. Yes.
So you have to take the RHS as 0.
Yes, RHS as 0 means your input should be 0. So take RHS as 0 and rewrite the equation so that this equation will become d square y of t by dt square plus 2 dy of t by dt plus 2y of t is equal to 0. Now we need to write the characteristic equation for this. Rakesh, number 87, you tell me how to write the characteristic equation.
R square plus 2R plus 2 is equal to 0.
Very good. R square plus 2R plus 2 is equal to 0. And you can solve the value for R. This is a quadratic equation. So R you can solve it by plus or minus root of b square minus 4ac by 2a. Or you can directly give to the calculator and tell me the answer for R. So if anybody don't know how to find the roots of a quadratic equation from the calculator, you need to study. So tell me the two answers.
So -1 plus minus I.
Yes, -1 plus j or -1 minus j. So from this, your real part is a, which is equal to -1, and imaginary part can be 1. I'm taking only the magnitude, not sign into consideration. Because the root is -1 plus or minus j, isn't it? So imaginary part is 1 and the real part is -1. Now, based upon this, since it is a complex number, you can see that the roots are complex number. So, based upon this, you have to write the solution. The solution is yn of t is equal to e to the power 80 into cos bt plus, sorry, c1 cos bt plus c2 sin bt. Now, what is a? A is -1. So, e to the power -t into C1 cos t, B is 1, right? So C1 cos t plus C2 sin t. Put it as equation number 1 because later we need to rewrite this equation after finding C1 and C2. Now to find C1 and C2, what we have to do? First, you take the first initial condition. The first initial condition that was given in the question was y of 0 is equal to 1. Any doubts, please ask. I'll go a little bit fast, okay, because repeatedly I'm doing same type of problems only, so you can also grasp accordingly. If any doubts, please post me and ask. Kindly mute yourself. One of you has muted. Unmuted. Who is it? Yeah, Krishnend, Rutesh, unmute. I mean, mute yourself. Krishnend and Rutesh, mute. So this was y of 0, the one of the initial condition. So what I will do is I'll put time t is equal to 0. So y of 0 is equal to 1. So 1 is equal to e to the power 0 into c1 cos 0 plus c2 sin 0. Sin 0 is 0 as already you know. Cos 0 is 1. So 1 is equal to 1 into c1 or c1 is equal to 1. I hope all of you got the value of C1. If any doubts, please tell me. Now to find C2, you need to take the second initial condition. The second initial condition was dy of t by dt at t equal to 0 is 0. Dy of t by dt at t equal to 0 is 0. So for this, we need to take the derivative of our solution. We know that y of t is equal to, what is y of t? Y of t is equal to e raised to minus t into C1 cos t plus C2 sin t. So to find the derivative, you need to apply product rule, correct? You need to apply product rule because we are having two functions. This is u and this is v. So kindly apply uv rule or product rule and find the derivative. Rakshita, tell me how you are going to apply the product rule. No response. You are absent. Sorry. Sai Kiran, tell me what is the product rule?
Sir, after applying the product rule, the expression that we'll get is minus e power minus t into C1 cos t plus C2 sin t.
Yeah, correct. Sai Kiran, tell me what is product rule?
Hello, sir. Am I audible?
Yeah. Yes, yes.
Yes, sir.
Yes, sir. Minus e power minus t into
Yes,
C1
you are
cos t
correct.
plus
You are
C2 sin
correct.
t.
Cyan, your answer is correct. I told your answer is correct.
Oh, okay, sir.
Yeah, Sai Kiran, tell me. Sai Kiran.
Sir, e power minus t into
E to the power
differentiation of
minus t
C1
into
cos t plus C2 sin t.
derivative of u is
Differentiation of
differentiation of v.
derivative
That
of v,
is
sir.
one.
Minus
Minus
C1
C1
sin t
sin t.
plus C2 cos t
Plus second term.
plus C1 cos t plus C2 sin t
Into.
into minus e power minus t.
Yes, very good. Minus e to the power minus t. So we have to put minus over.
Minus e
Yes, so I'll put minus over.
minus t.
Now you will put 0 after putting 0 because initial condition is defined at t is equal to 0. So it will become e to the power 0 into minus c1 sin t will become sin 0, cos t will become cos 0, minus again we are having c1 cos 0 plus c2 sin 0 into e to the power 0. So your answer will be e to the power 0 is 1. This will become 0. This will become 1, isn't it? So only C2 minus of this is 0. This is 1. So 1 into C1 is C1. So answer is C2 minus C1. Correct? C2 minus C1. And in the left side, you are having 0 because it is given that the initial condition is 0. So 0 is equal to C2 minus C1. And already we found the value of C1. C1 was 1. So C2 is equal to 1. Okay. You got this now? Sayan, you got the answer?
Yes, sir.
Yeah. So no need to simplify. Just you take the derivative and I mean you can substitute the initial conditions as such. Now after finding C1 and C2, you will substitute in equation number 1 so that your natural response will be, it can be rewritten as yn of t is equal to e to the power minus t into C1 and C2 both are 1. So it will be cos t plus sin t. This is your final answer. Any doubts? So as of now, we did natural response. Now we are moving towards forced response. From the name itself, it is understood that we are not going to set your input as 0. Here we will be giving some input. We will be giving some sort of force to the system so that the system will work over that input and produce the output. Okay, so all of you take one table. So this table you need to study to get the solution. Draw the table. In the first column, input x of t. In the second column, particular solution. Particular solution means yt of t. This is nothing but output corresponding to a particular input. Output corresponding to a particular input. That is called a particular solution. For this, we are having three different cases. One is if you are giving an input as a constant. First case is if you are giving your input as a constant, let it be capital A, then your solution will be A. It will be another constant because input is constant, right? So output will be also constant. Now, if you are giving an exponential signal like this, A into e to the power 80 or minus 80, A into e to the power minus 8 you can put. Then correspondingly your particular solution will be k into e to the power minus 80. And third case, if you are giving a cosine waveform of amplitude A and frequency omega, that is A cos of omega t plus phi, where phi is the phase difference. Then your output will be k1 cos omega t plus k2 sin omega t. K1 cos omega t plus k2 sin omega t. So these are the three cases for forced response or particular solution corresponding to your input x of t. Earlier we dealt with natural response. Now we are going to deal with forced response. Okay, now forced response is equal to, all of you take down, forced response. Forced response can be represented as yf of t. Okay, yf of t is equal to natural response yn of t plus the particular solution yp of t. So to find the forced response, first of all, we need to find the natural response. Natural response is something which we have done previously, same format. That we have to find. Then we need to find the particular solution corresponding to the particular input. Then we need to add these two to get your final output, that is yf of t. I repeat, force response is the sum of natural response and particular solution. Natural response means the output only depending upon initial condition. Okay, plus the output corresponding to your particular input, that is your particular solution. So particular solution plus natural solution will give you the forced response. So this logic you need to apply in the upcoming problems provided with this particular table. So all these three cases you need to study. So correspondingly you will be applying the solutions. Now take down the problem. Determine the forced response for the system given by 5 dy of t by dt plus 10 y of t equal to 2x of t with input x of t equal to 2u of t. So in the earlier problems and all, we were not given your input, isn't it? But in this we have input because we are about to find the forced response. That is why they have given the input x of t. So based on this input x of t, we need to find the particular solution as well as the natural response, and then we need to add. So solution, first I will come with natural response. Natural response. So for that, what I have to do? Previously, what we have done, same thing, you just write. You have to replace your right hand side by 0, means your input should be 0. So it will become 5 dy of t by dt plus 10 y of t is equal to 0. The characteristic equation will be 5r plus 10 is equal to 0. 5r is equal to minus 10 means r is equal to minus 2. Now tell me what is your yn of t now. Don't find the value of c, c1, c2 and all. I'll tell when to find. But you need to tell me the solution based upon the roots. What is the root over here? R, which is equal to minus 2. Based upon this, what is your solution? Satvika?
Sir, C1 e power minus 2t.
Even erase. Okay. Satvika, tell me what is the output solution? Yes, Sayan, it is correct. Satvika, tell me what is your solution based upon r equal to minus 2. No idea, no response. Sukita, Raghu, tell me what is your output?
Sir, C1 e raised to minus 2t.
Very good. C1 e to the power minus 2t, like equation number 1. Okay, I'll come to this equation 1 later. Now we are going for the particular solution. Second case, particular solution. Now we are not going to find C1. I will tell when to find C1. Okay, later I will tell. Now before that, I should find the particular solution. Now for this, I need to check the table. You tell me after observing this table, which case you need to apply. Which case you need to apply. Your input is, what is your input that is given? Your input was 2u of t. U of t is 1. So it is constant, right? X of t is equal to 2. So it is a constant. Correct? So which case you need to check? You need to apply case number 1. So based upon this, your particular solution will be K. Your input is equal to 2. Input x of t is equal to 2, which is a constant. Therefore, by using the table, we can write the particular solution as K. Let it be equation number 2. Now this you will substitute in the given equation. What is the given equation?